Okay, let's start. So today we will talk about the control structures. The control structure can be used to describe some conditional cases or iterations. So for the conditional cases, we have if, else, switch. The application needs to make a decision about the code direction based on the current expression. The other iteration need to do some task by loops, and you need to set some expression control the loop. Whether you continue to run the loop or stop. For the iteration we have and do well. So this is a typical if case. Here is the expression of value. Value is first. If it's true, then you can do that. Other one, you will get it true here. So this block implemented by this sentence. So here is some example of the statement, if statement. So if your action or task is in one line, one sentence, you don't need to have any meaning. However, if you have multiple sentences, this is totally different from Python. In Python, they distinguish whether this is a key sentence belongs to the same after the space here. But for C, you have to add the E. So this is not correct. The key is only control the first sentence. Now the second sentence is not controlled by the E. It will always you can add and. So if both conditions in the first if are true, you are one. So if any of these is true, this is not correct. They evaluate whether it is true or not. If you want to evaluate for this is always true. So you can replace this by one. In that way, though, this action always executed. So for these errors, for this kind of report, you can write the if like this, but you have two if sentences. All you can write them. They are the same. However, the second one may have a better performance because you compare the outline and combine this into one branch prediction. However, the first one may have. They are equal when you run the code. However, for the hardware, from the hardware perspective, they may have slightly different. Here, this one may have only. This one may only have one branch prediction. This two. So you can see that in order to implement one if for C language, you need to write these sentences at assembly language. So you need to move data a lot to some special or general purpose register and then either same or not. And then do the action. So you can see that the C language actually significantly simplifies our task. So this is if else. You have a two parallel code passes here. This is what happens if it's true. This is what happens if it's not true. Yes, if it's not true. And then you can see that this if else can be implemented by the assembly sentences. Each task is translated into multiple sentences here. Compared to the purest if sentence, this condition is very simple because the value is 0 or not. So that's the reason why the first two sentences can do that. The first assembly language sentence can do that. Well, in purest example, we use at least 4 or 5 sentences to evaluate the condition. So the else is always associated with the code this it means that on this else always code is this one. And this one always will be this one. Although there is no signal here. No signal here. This one here. But if you write something like this one now will be first. So you always use these signals to control else this one on this. You can have a lot of it. By else if sentence, you can evaluate one condition. This is a while loop. While loop means that if the condition is true, we always run this. If this condition is false, then you jump out of this loop, go to the next instruction here. Then this is one example for the loop. At the beginning of the loop, you evaluate the condition. So at the end of the loop, you jump to the condition again, evaluate the condition again. If the condition is true, then you always successfully. And at the end of the loop, you jump to. If the loop is false, then you go to here. And you do not run the loop anymore. So this type of loop, why? Because you didn't change the value inside the loop. So the x is always smaller than 10. And the condition here is always true. This type of error cannot be corrected or found by the compiler. You have to hack it yourself. This is a for loop. In the for loop, there are three parts. One is the initialization. The second one is condition, the end condition. And the third one is the reinitialization. So here is the control block. This is the task. The first one is initialization, and this is task. And then the reinitialization. You can write loop value of safety here, which is this. So after initialization, the condition, test the condition. If this is true, then you will go to the loop, and run the loop, and then run the reinitialization, and go back to the test condition until it's false. If it's false, you go out of this loop and run the next instruction. And this is a for loop example. So you can see that in the for sentence, we initialize the x to 0. And the test condition is whether the I is smaller than 10. The reinitialization is I plus plus. So this loop can be translated to this one. So you can see the first two sentences are the initialization. And then we have the test here. And then we have the reinitialization. You can write all the loops. There are some examples of the for loops. and you can try to run the for loop yourself. So the first one is just a print out from 0 to 10. The second one is print out the letter from A to Z. Oh, it's not a capitalized letter. The last one now comes how many ones? Of course, how many ones are in a binary form representation of that number. And you can write multi-dimensional loops, which is nested loops here. So here you have four loops. They can each dimension is controlled by one variable. So we have no so the loop body here is enough. The inner loop will be run for 10 times. And the outer loop will run for 10 times. So totally we will run this piece of code. We will run this piece of code for 100 times. But this one for 10 times. So for the first example, these two variables have no relationship. So that's the reason why you have to run it 100 times. But for this one, the second example, these two have some dependency. And you are modifying one of the variables inside. So if you have a counter, then you may prefer the full loop because you can easily use the counter to control this loop. And you can clearly write how the counter is modified inside the loop. If you only have a condition, then the while loop is preferred. You can check this condition each time. If this condition still holds, then you can run the loop body. Otherwise, you can stop the loop. But they are equivalent. You can change any for loop to a while loop, and you can change any while loop to a for loop too. So this is a do while loop. Do while loop means you don't evaluate any condition. You just run the body, loop body for once, and then evaluate. At the end of the loop body, if some condition hold, then you have to go back to run the loop again. Otherwise, you can stop. So the difference between a while loop and a do while loop. Do while loop, do the jump first, do the loop first, loop body first, and then evaluate. While the while loop will first evaluate the condition. Only when the condition holds is true, you will run the loop body. So we can use these condition sentences to solve different problems. For sequential problems, it's normal case sentences. If you need a condition, then we can use if else and speed. If you have a iterative task, then you can use well for now. For example, the problem example is computing pi. The constant pi can be calculated like in this way. And this is the algorithm of the decimal computer. The most important block here is this one. We can further break it into a for loop like this. First, we can initialize the iteration counter. If the counter is smaller than the number of terms, then we will do the loop by do the constant inside the loop. Otherwise, we can just stop. So we can further break the loop body into this control flow. We can use if else to implement this. If the counter is we can evaluate whether the counter is odd or even. If it's odd, then we do the subtraction. Otherwise, we do the addition. So let me go back to the. So this is the equation of the time. We have different terms for the odd is positive. 1, 3 are positive, but the 2, 4 are negative. So that's the reason why we need a counter. So we can write how to compute the time in this way by one for loop and one if else sentence. And we can write the C code in this way. We need to include the stdio. In that library, we can use the printf scan. The scanf means it will receive a input from the keyboard. Here, it will receive the number of terms you want to compute from the keyboard. And then use it as the condition for the for loop here. And eventually the printf will print out the type here. The second example is to find the prime numbers. For example, you can print out all the prime numbers smaller than 100. A number is a prime if it's only divisor of one itself. All non-prime numbers must not have a divisor. So you can first use this vocabulary to describe the problem. If you have an initialization without the primes here. For the printout block, you can further break it into this one. Basically, you can scan all the number from 2. Between 2 and 100. and then check whether it's a prime or not. If it's a prime, then you just do the printout. So how to check whether a number is a prime or not? So you need to divide the number by 2 through 10. If there is no divider, then you can print out. Otherwise, you just keep them. So this simple can overbreak on this point cloud. We can use a for loop, another for loop to run this. So we basically will try different dividers from 2 to so we can keep track whether number was divisible by use of flag. If the flag is true, then the number is a prime. If it's a false, then it's not a prime number. We can define the subnumber. Constant variable. Yes. So the true means so you can recall that we also have a variable in assembly language. So eventually the example can be implemented by this piece of code. And the first loop will scan the number from 2 to 100. And the second loop here will try different divider. And inside this second loop, the flag can be set to false if some conditions are met. If no condition is met here, then the number is a prime. So in this way, we can pick up all the prime number less than 100. Another very powerful code structure is the switch. The switch is controlled by one expression. And you can, the expression here can be different values. Each value can be and the default is also. So at the end of the case, each case needs to write break. But the last case you need to do back. The break means you will go to the next sentence, not inside this block anymore. If you do not write the break, then the it will continue to second case here. So here is the control flow of this switch sentence. So you first evaluate the expression. If this is the first case, then you go to the first act. If this is second case, then you go to the second direction. Second the break here can help you to implement this. If you do not write the break, then it will continue to this path. Here is one example. We have a variable named month. The month can be from 1 to 12. For different value of month, you want to do different tasks here. Then you can write different tasks here. If you do not have task, you don't need to write something. Write a case here. If you write case here and have nothing, it will do nothing. But for all the meaningful tasks, cases here, they always have a break. So in this example, we don't list all the possibilities here. For example, we don't have a month 5. The 5 will be represented in 4. 7 is, we don't list the 7 either. So the 7 will also be represented in the default case. We cannot write the case in this way. The value after case must be a constant. For example, a number or a char. It cannot be a variable like I or X. You can only write the variable in the switch domain. So you can see that in this example, no break. If A is 1, then it will print out A, B, C, because there is no break. If A is 1, it will go down to all the cases here. If A is 2, then you will print out B, C. Otherwise, it's just print out B. So this is what happens if you have no break. So we will use the switch to implement a example. This example is searching for a substring. So the user will type a line of text, and you will print out the number of this word. You will try to find and count how many this word in the sentence. And you can use this function to receive the text typed by the user from keyboard. And in this example, we will use statement. So this one is similar to the so-called finite state machine. And this finite state machine can be implemented by this switch block. we have three conditions here. Max 0, minus 1, max 2. And then we can write this piece of code to implement that example. So in this code, we have a char. Char is a variable used to store the data typed by the user. And the match means how many chars until now. Counter means the number of string matched. So we will constantly receive some passed by the user from keyboard until the user implement this, input this. And then we will do a switch on the match. We will have three cases. 0, 1, and 2. And in each case, we will check different conditions. Only when the last condition false, we will increase this count. At the end of this code, we will print out the discount. So there is a very important keyword for the switch, which is a break. The break means pass the control out of the smallest statement containing it to the statement immediately following. So it only used by the switch statement or the iteration statement. There is another similar keyword, which is a so-called continue. The continue means it will stop the execution of the loop body for this current iteration. So you can try this piece of code. If we do not have this syntax, this piece of code will print out the I from 0 to 20. But if we have this, when is that even number, it will do a continue. It will go to the next iteration. We will not run this out. So with the continue here, we only print out the odd number. An easier way to implement this is that we can initialize this I1 and the +2. Any question? If no question, we can stop it. Thank you very much. I know this may be easy for some students, but we have a student from technology who would like to, cover this part for them. Thank you very much.